In this part of the video, we'll see the arithmetic operations which we can perform in various number systems. So, to start with, we'll first see the binary arithmetic operations, and then we will see the arithmetic operations in octal number system. The other operations or the arithmetic operations in other number systems you can try by your own, or you can ask about them in your tutorial class if you have any doubt regarding them. Even if you have doubt, you can ask me in the doubt class. So I leave that for time being, but I will consider the binary arithmetic operations and the arithmetic operations in the octal number system. So let's start. So to perform the operations in any number system, we want or we should have some rules. So the rules of the binary number system in to perform the operation in the binary number system, we have to consider certain rules. So as we know that if we perform addition of zeros in the binary number system, the answer will be 0. 0 plus 1 will give 1, whereas 1 plus 0 will also give 1. But 1 plus 1 in decimal number systems becomes 2. But in the binary number system, as we only have 2 symbols, so we cannot get a new symbol, but the answer will be therefore not 2 but 1 0. Similarly, the subtraction can be done with the help of 2 bits. So if we subtract 0 from 0, we get 0 as the answer. But if we subtract 0 from 1, the answer will be 1. Whereas 1 minus 1 will be 0. And we cannot subtract 0 from 1 in the binary number system. But if we subtract 0 from 1, then we have to borrow. And this will become as a signed number. It will not be an unsigned number. So 0 minus 1, to do 0 minus 1, we have to borrow from somewhere. So the borrowing part has to be taken, and this borrow, if we get the borrow from somewhere, then it becomes 1 0 minus 1. And 1 0 minus 1, 1 0 is equal to 2. So then 2 minus 1 will be equal to 1. Similarly, the multiplication if we'll do, the rules for multiplication are very simple. So 0 into 0 is 0, 0 into 1 is 0, 1 into 0 is 0, and only 1 into 1 will give 1. Similarly, if we want, we can see the division also. So 0 by 1 is equal to 0, whereas 1 by 1 is equal to 0. The 0 in the denominator is not allowed in any of the case. So division is possible only in 2 cases. Now let us see the rules, the application of the rules with the help of examples. In this first question, if we see, so to perform the addition of 2 numbers which are 0, 0, 1, 1, 0, 0, 1, 0 plus 0, 0, 1, 1, 0, 0, we have to do something as this. So 0 plus 0 gives you 0, 1 plus 0 gives you 1, 0 plus 1 gives you 1, 1 plus 1 gives you 1 0. So 1 becomes carry and 0 is written here. Now 1 plus 1 becomes 0, 1, again 1 0. So 1 is carry, 0 is here. Now 1 plus 0, 0 will become 1. Now there is no digit, so 0 plus 0 is equal to 0. So now the answer will be 1, 0, 0, 1, 1, 0. We can check this by converting the number in decimal number. So if you have any doubt, you can convert the given numbers in decimal and then perform the addition and check the answer. But if in a certain exam or in a quiz it is asked to perform the addition directly, then you should be able to do the addition or the arithmetic operation directly with the help of the rules. If you do the division or if you convert the number, then it will not be treated as the correct answer. Moving on to the subtraction part. To perform the subtraction of two numbers, let us say the two numbers are 0, 0, 1, 1, 0, 1, 0 minus 0, 0, 1, 1, 0, 0. We want to subtract 0, 0, 0, 1, 1, 0, 0 from 0, 0, 1, 1, 0, 1, 0. To do this, we again have to use the rules. So 0 minus 0 is 0. 1 minus 0 is 1. Whereas 0 minus 1 is not possible. So we have to borrow. Okay. So borrowing 1 from the previous bit, from the next bit I should say. So it becomes 1, 0. So 1, 0 minus 1 is 1. So 1. Now from where we have borrowed, it becomes 0. So again we will borrow it from the next step. Borrowing it from the next step, from the next bit becomes 1, 0. So 1, 0 minus 1 is 1. Now the remaining bits are 0, 0, 0. So subtracting 0, 0, 0 from 0, 0, 0 will give you 0, 0, 0. So this becomes our answer. So we have used the rules to do the subtraction. Now let us move on to the multiplication. So to do the multiplication, we will use the rules of multiplication. And multiplication is quite simpler because 0 and 1, we are very much familiar with these numbers in our decimal number system. So to perform the operation in decimal number system, the binary number system, it is same as the decimal number system. So this is very simple and easy to understand. You can try it by your own. If there is any doubt, you ask me in the doubt class. Moving on to the next part, which is octal arithmetic. So the octal arithmetic we'll try to understand with the help of examples and the rules. We understand that if we try to sum two octal numbers which are from 0 to 7, then the answer will be somewhere from this table. So if we multiply, let's say 3 with, if we sum two octal numbers, let's say the octal number 3 with the another number 5. So if I add them together, so you see what we will get, the answer will be 5 plus 3 will not be 8 because 8 will be the decimal number system. In the octal number system, the answer will be 1, 0. So if we want the answer of any two octal numbers, then we can use this table to perform the sum of single bit octal numbers, single digit octal numbers. Considering this, if we perform the addition of two octal numbers 4, 5, 6 and 1, 2, 3, then we have to use the rules. So 4 plus 1 will be equal to, we have to take 4 from one of the table and 1 from the other table. Oh, sorry. To do this, we should start as per our learning of the arithmetic operations. We should start from the LSB side. So we'll start with from the LSB side. So 6 plus 3. 6 plus 3. So we have to take 6 in this table from on one side. So let's say this is 6 and 3. So 6 plus 3 will be equal to 1, 1. So in this table we have noted down 1 and the carry forward is 1. So in the next step we have to sum 1 plus 5 plus 2. So let us see. 1 plus 5 is 6. 6 plus 2 is 1, 0. So the answer is 1, 0. So 0 is noted down here. 1 is again becomes the carry. In the next step, we have to consider this 1. So 1 plus 4 becomes 1 plus 4 is 5. Now this 5 plus this 1 becomes 6. So we have to note down 6 here. So this is how we can perform addition. Now based on this thing, based on the same table, we can use it. The same table can be used to perform subtraction also. To perform the subtraction, you can do it by two methods, but I'll show you the simpler one. So we have to subtract. Let us say 173 from 456. Now both the numbers are given in octal. So to subtract this, we have to do 4 minus 1. We have to start subtracting from the LSB. So LSB is 6. 6 is greater than 3. So it will be 6 minus 3. So the answer will be 3. Now the next step is 5. So 5 minus 7 will be equal to how much? 5 minus 7. Now if you have to do this type of subtraction in which the quotient is the number which has to be subtracted is greater than the number from which it is to be subtracted, then the simple method which we do is, if suppose I subtract 7, if I have to subtract 7 from 5, but if I suppose subtract 5 from 7, so then the answer will be 2. Now this 2 should be added to 7. Then we get as 7. Next is 1, 0. Then 1, 1. Then 1, 2. And then 1, 3. So 1, 3. Maybe it is not clear to you. So let me answer it in a different way. So to perform the subtraction, we have to do it in the another way. So the other way is by using the same table. So what we will do is, we will take this number 456 minus 173. So we start with the LSB. So 6 minus 3. So you see 6 is here in this table and you have to subtract 3 from this. So you see this 3 in this 3 table, where is the 6 is coming? So if you subtract 3 from this, it is coming 3. So the answer should be 3 here. The LSB should be 3. Now let us take the another number. So now this is less than this. We have to do 5. 5 minus 7 in the octal number system. So 5 cannot subtract 7 because 5 is less than 7. So we will borrow 1 from this digit, from this next digit. So this will become 1, 5. Now 1, 5 minus 7. So we have to see 1, 5 in the column of 7. So 7 column in this 1, 5 is here. Now if I subtract 7 from 1, 5, the answer which I will get is 6. So the answer should be 6 here. It is by mistake, it is written 3. So we should write it 6 here rather. It should be 6, not 3. Then here, after borrowing, it became 3 rather than 4 because we have borrowed 1. So 3 minus 1. So we see 3 in the table. So 3 and then 1. So we have to see in the 1 table. So 3 minus 1. So this will give us 2. So here 2 should come. So instead of 3 this, it should be 2. So the answer should be 2, 6, 3 rather than 3, 3, 3. So it is by mistake I have written 3, 3, 3. So correct this, and still if you have any doubt, ask me in the doubt class. Moving on to the next slide. But before moving to the next slide, let me clarify it once again that you can use the same rules, similar rules, to perform the addition in hexadecimal number system or in any other number system. You try it by your own, ask them in the tutorial class, or ask to me in the doubt clearing class. So we will clear those things in the doubt clearing class. Now let us move on to understand the complements of the number system. And these complements are very much used in performing the subtraction of two numbers in any number system. Usually it is used by the computers to perform the subtraction. And this method is very much useful because we can subtract without designing the subtractor, because whatever arithmetic operation we have to do, that arithmetic operation in computers can be done by the help of hardwares. If we do not have complements, then we may have to design two separate circuits to perform addition and the subtraction separately. But we can use adder itself to perform the addition operation as well as the subtraction operation. But for that, we should be able to calculate the complement of the number. In any number system, we have two complements. One complement, which is the higher one, is called the R's complement, whereas the lower complement is called the R minus 1's complement. In the decimal number system, R's complement is also called 10's complement, whereas in the binary number system it is called 2's complement, octal 8's complement, and in the hexadecimal 16's complement. The R minus 1's complements are 9's complement in decimal number system, 1's complement in binary number system, 7's complement in octal number system, and 15's complement in hexadecimal number system. Here in this slide, I will discuss the general method to find the complement. Later on, we will understand the same thing with the help of examples. To find the R's complement, the general formula is R to the power n minus n. This n is a small n, whereas this n is the capital N. Let me clarify what these notations mean. N is the given positive number, the number for which you have to find the complement. R is the radix or the base of the number system. Then n is the number of digits in the integral part of the number. That is the number of digits before the point. So this is the general formula to calculate the R's complement of any number. We will understand this with the help of an example. Later on, we will use the R minus 1's complement also. So the general formula to determine the R minus 1's complement is to determine the R's complement, which is R to the power n minus n, and then subtracting the R to the power minus m from the R's complement. So R to the power minus n is nothing but the m is here nothing but the number of digits in the fraction part. So we have to consider this part. So if we find this, then we can find, if we can find r's complement, we can find r minus 1's complement directly. Or other way around, if we are able to find r's complement, then we can find r's complement directly from it. Let us understand it by the help of examples. Both the complements we will understand with the help of examples. Let us first try with the lower complement. So here we will calculate r minus 1's complement first, and then we will compute the r's complement later on. To compute the r's complement, we have to compute the r minus 1's complement, the formula which we have just now seen give us this. So 9's complement of a number, let us say we have to determine the given number is 5, 4, 6, 7, 0, 0 in decimal number system, and we have to determine the 9's complement of this number in the decimal number system. So we have to take all the 9's, then subtract the given number, which is our given number. So given number is this n, whereas r to the power n minus r to the power minus n is nothing but this. N is your maximum number of digits and m is the number of fraction digits. So in this particular question, the digits after the fraction is 0. So this part r to the power minus m becomes r to the power 0, and r to the power 0 is nothing but 1. So we'll consider 1 here. Whereas this part r to the power minus r to the power n is our this part. So to consider this, we have to calculate this part. So r to the power n is how much here? 3, 4, 5, 6. So if I raise 10 to the power 6 and then subtract 1 from it, so we'll get this. So this is then subtracted from the given number is subtracted from this, we get the answer as this. So this is the general method. Now using the same logic, we can compute the 7's complement, 15's complement and the 1's complement of the number. It is very simple, it is not difficult. The simpler method, or just for memory, I have explained you how to do it, but for the memory you can just remember that if you have to determine the lower complement, then subtract the given number from all, let's say 7, let's say all f. So f's are 15 in the this 15's complement. So 15's complement in the hexadecimal number system, f is equal to 15. So we have to consider 15 for every number. This will be not difficult, this will be very easy for you. So let me explain this. The 15's complement of a number 5A3D.2.B. If we want the 15's complement of this number, we will subtract this number from FFFFF.F. We'll subtract the given number from FFF all f's point F. So then what we get is, let's see what we get. So subtracting this f, this 5 from f, we get this f is equal to 15. So 15 minus 5 is equal to 10. So 10 is nothing but a. Similarly, 15 minus a. So 15 is, f is 15. So 15 minus a is 10. So 15 minus 10 is 5. Then we take 15 and subtract 3 from it. So 15 minus 3 is 12, which is equal to C in the hexadecimal number system. Similarly for others, we have to do, and we get the total complete 15's complement of a given number. This way we can find the complement of a given number. Now let us move on to find the r's complement of a given number. To find the r's complement, we can use the same numbers which we have used to find the r minus 1's complement, and now rather than doing any other thing, we will do it by a simple trick, and that trick is we will take the r's complement, which is this, and we have to add 1 to it. Why 1? Because this part is now, previously we have subtracted this part, now this part is not there, so to remove this part we will add 1 to the r minus 1's complement. So it becomes very easy to get the r's complement of a number if we can find the r minus 1's complement of the given number. And r minus 1's complement is also very easy. You take the biggest symbol in the number system and subtract the given number system from the number formed by the biggest symbol. In case of decimal number system, the biggest symbol is 9, so we take all 9s and then subtract the given number from all 9s. Similarly, for the other number systems, to find the r's complement, we have to add 1 to the r minus 1's complement. So in the previous question, the r minus 1's complement was 453299. Then this was the r minus 1's complement. To find the r's complement, we have added 1 to it. Oh, that is missed. So I am sorry for that. This one I have missed. But you write it. Then the answer will be this. Similarly for the other number systems. So you will see that the answer is not, there is not much change, but change of 1 digit only, the LSB. So this is how we can find the r's complement and the r minus 1's complement. Now a quiz for you. So the quiz is that find 5's and 6's complement of the given number 24035.21 in a number system with 6 symbols. So the radix of this number system is 6 and we have to find the r's complement, that is 6's complement, and r minus 1's complement, that is 5's complement of the given number. You have to try this question by your own and answer this question to me in the doubt class. If you have doubt, you can ask me in the doubt class. I'll show you the answer in that class. Moving on to the next part of this lecture. This is the last part of this lecture. Now, as we have found the r's complement and r minus 1's complement of a number, the question is, what is the use of this r's complement and r minus 1's complement? The use is very interesting. We can use the r's complement and r minus 1's complement to perform the subtraction. So in the computers, the r's and r minus 1's complement are used to perform the subtraction of the given number without using the subtractor as an hardware. We have to use adder as an hardware, and the adder itself can do the operation of subtraction. To do this, we have to take the r's complement of the number which we want to subtract. So we take the r's complement. Let's say we have to use the r's complement. Then we take the r's complement of the number which need to be subtracted. Then after getting the r's complement of the number, we add this r's complement of the number to the number from which the original number has to be subtracted. Then if we add them, there can be two possibilities. There can be the AND carry or there cannot be the AND carry. If AND carry is generated, then we discard it. If AND carry is not generated, then we take the r's complement of the result and place a negative sign in front of it. So this is how we get the complete answer, by using R's complement and by performing addition, not the subtraction operation. Similarly, we can use R minus 1's complement to perform the subtraction by performing addition of the R minus 1's complement to the given number. To use the R minus 1's complement method, again the procedure is more or less same. We take the R minus 1's complement of the number we have to subtract, add it to the number we are subtracting, and then we have to check the result. If the AND carry occurs, in the previous case we have discarded or ignored the carry, but in this case if the carry is generated, we add back the carry to the LSB. The other option is that there is no carry. If we perform the operation and then there is no carry, if no carry is generated, then we take the R minus 1's complement of the result and place a negative sign in front of it. So we will understand this with the help of an example. Let's say subtract using tens complement. So the two numbers given are 72532, and we have to subtract 3250 from 72532. Now the two numbers, as doesn't have equal number of digits, first we have to make the number of digits equal in the two numbers. So we put a 0 in front of 3250 to make the number of digits equal in both the numbers. Now we take the R's complement of this number, which is the tens complement of this number. To take the tens complement of this number, it is very simple. We take the nines complement of the number and add 1 to it. So the nines complement of the number is, we have to subtract this number from all nines. So if we subtract this number from all nines, we get 9 minus 0 as 9. So 9 minus 3 as 6. 9 minus 2 as 7. 9 minus 5 is 5. And 9 minus 0 is 9. But we have to add 1 also. So adding 1 will become 1 0. So our answer, the tens complement of this is 96750. This number, if we add to this number, then the answer will have a carry. So that carry we have to discard, and our final answer will be 69282. On the same lines, if suppose we have to subtract 72532 from 3250, again the procedure will be same, but now we have to take the tens complement of this number. So tens complement of this number is found as this. So tens complement of this number, if you will find, so subtract all the digits from 9 and the last digit from 10. So again you will find this, add both the numbers, and we can see that as there is no carry is generated, then we have to take the R's complement of the number and place a negative sign in front of it. So this is the complete procedure to find the R's complement. To find the answer using, let's say we perform the subtraction in 2's complement method. So again it is R's complement. To perform the R's complement, we have taken two cases. In one case we have subtracted, this is, let's say, our number x, this is our number y. So in first case we have subtracted y from x, in the second case we have subtracted x from y. if you perform the addition, if you have to perform this operation, then in the first case we have to take the complement of 2's complement of y, and the 2's complement of y is this. Add it to the number, carries generated, discarded. In the second case, take the 2's complement of x, write it, add it, no carry is generated. So as when no carry is generated, we have to, if no carry is generated, then we take the 2's complement of this number and substitute or put a minus in front of it. This is how we perform the subtraction using 2's complement. You try to subtract the numbers using r minus 1's complement, that is the 9's complement and the 1's complement. If you have any doubt related to them, you ask me in the doubt class. I will clarify them. Else, you can ask them in the tutorial class also. Now, let us see. Okay, so we have finished this lecture. In this lecture, we have learned about various number systems and how these numbers are, what is the reason of using so many number systems. So in short, we have seen what are the various number systems, and the reason to use these various number systems is nothing but the convenience and to the interaction between man and machine. The other thing we have seen is how to convert any given number in any base to decimal number system, and also the vice versa. So to convert a given number in decimal number system, we use the general polynomial notation method and multiply the place value with the face value in the given base. Later on, we have studied that how to convert a decimal number system to any base, to any other number system with any base. To do that, we have to do continuous division. That division has to be done up till the quotient is less than the base itself. Then, to get the answer, we have to write the integral part in the reverse order, whereas the fractional part is to be multiplied with the base, and the remainders or the integral parts has to be written in the, not in the reverse order, but the forward order. Then we have seen the various complements, the arithmetic operations, and how to use this r's and r minus 1's complement to perform subtraction. In this lecture, this is what we have seen. Might be I might have, during the discussion, I might have missed something, or there are a few mistakes in the presentation. So you try to correct them, or if you have still doubt, you ask me in the doubt clearing class about all the mistakes, identify them. It will be a good exercise for you as well. We'll clarify everything in the doubt clearing class. Thank you for listening this lecture. Thank you everyone.